Okay, so I'll be doing the next example. I'll be doing one more example, as I have said, in the powers of um x minus a and y minus b. Okay, let me consider an example here. The question is expand e power xy in powers of x minus 1 and y plus 1. Okay. So here I should be clear that I'll be going with the second one. I'll be going with the first formula. Second one I've already used. The first formula, for the first formula, first I will consider let f of x comma y, nothing has been given here, to be e power xy. Okay. Now I'm being asked to find in the powers of a and x minus a and y minus b. See here, actually it is x minus a and y minus b. Na? So in the place of b, I have a plus that implies that b is with a negative sign. Okay. Yes. So I'll be going with fx, of course, fx, that is the first derivative of f with respect to x. I'll be finding out for the Taylor's expansion. Expand, of course, this is Taylor's expansion. Fx I'll be doing, that's nothing but dou f by dou x, which would be what? E power x, actually it is like e power x is there. So e power x derivative would be e power x only. Okay. xy again as a function. So x derivative, I should be doing like this, guys. xy. Okay. So what does this imply? E power x derivative, 101 times if you do also, it's e power x only. But xy derivative with respect to x would be 1 into y. Because y is a constant with respect to x. Okay. Next, fy I'll be finding out, which is dou f by dou y. This would be what? E power xy. E power x derivative is e power x only, but then I have a function of functions. So dou by dou y of xy, I'll be doing e power xy. X derivative would be, x would be a constant, y derivative would be 1. Okay. Next, I'll be doing double derivatives as well. How many terms you need to find out depends on the zeros that I'll be getting. If I have at least 3 terms should be there in the expansion, guys. So non-zero terms, 3 non-zero terms should be there. Okay. So fx6, so how I will do is dou by dou x of fx. Already I have taken the derivative of f with respect to x. Once again, I'll be taking the derivative. So this is my term. What's that term? Y into e power xy is my term. And I'm differentiating it again with respect to x. So y is a constant. E power xy derivative is e power xy. And xy derivative would be 1 into 1. Okay. Yes. Now, fxy, if I take, it's nothing but derivative with respect to y, fx derivative with respect to y, or fy derivative with respect to x. Okay. So fx is nothing but this term. This is fx term. So with respect to y, what? Both the terms, y also has y, e power xy also has y. So uv rule I'll be using. Derivative of uv would be what? U prime v plus uv prime, right? Okay. So derivative of y would be 1. E power xy is as it is plus. U, in the place of u, I have y. E power xy derivative is e power xy only. Xy I'll be differentiating with respect to y. Dou by dou y na. So I'll be differentiating with respect to y. So I'll be getting x into 1. Okay. That would be my fxy. Okay. Now what would be fyy? Let's see what would be fyy. It's nothing but one more time derivative of fy with respect to y. F suffix y with respect to y once again. Okay. So what I'll be getting, what is my fy? X into e power xy. This is what? X into e power xy. Okay, with respect to y I'm doing, so x is a constant. E power xy derivative is e power xy. E power xy also would have been constant if y would haven't been there. But since y is there, e power xy, y is there. So this derivative, e power xy derivative is e power xy. Now, x is a constant, y derivative is 1. So, fyy would be something like this. How many terms do we expand? If you have a doubt, first thing is, about the point, please do check, guys. If anything goes to 0, then you need to expand up to third order derivatives. If nothing goes to 0, then you can finish off with the second order derivatives. Okay. What exactly I mean is, first thing is I'll find out f at 1 comma minus 1. I hope you're understanding why it is 1 comma minus 1, because it should be x minus a and y minus b. Okay. In the place of b, I have 1, but in the place of minus, I have plus. So it should be minus of minus, right? So it is f1 comma minus 1. So e power minus 1 is what I have here. fx at 1 comma minus 1 would be what, guys? fx is this. Okay, y is minus 1, e power minus 1. Okay, yes. fy at 1 comma minus 1 would be what? X is 1, e power minus 1. Okay, next. Coming to this. What is this? This value would be what? Y square into e power xy. Okay, so y is minus 1. Y squared would be what? Minus 1 whole squared, which is plus 1. 1 into e power minus 1. Okay. Yes. Now, this term what I have got, let me simplify first. E power xy is common in both the terms. So, if I take it out, 1 plus, what's this? X into y. 1 plus x into y is what I have. So, e power minus 1 into x is 1, y is minus 1. So, this term goes to 0. Okay. I'm sorry. Let me not write here. I'll write it here. With this blue pen as well. I mean with this blue color, I will write here. fxy at 1 comma minus 1 would be what? E power minus 1 into 1 minus 1. So this would give me a 0, right? 1, 0 is fine. But if every alternative term is going to 0, then you need to go with the third order derivative. fyy at 1 comma minus 1 would be what, guys? This is nothing but x square into exy, right? So this would give me what? X square is 1, e power minus 1. Okay, so finally I'll write the Taylor series expansion. Please look at it. Taylor series expansion of f of x comma y, which is equal to e power xy in powers of x minus 1 and y plus 1 would be, how will it be? E power xy. This is equal to f of 1 comma minus 1 plus 1 by 1 factorial into fx at 1 comma minus 1. Okay. I should be having that also, right? The powers of x minus 1 into fx at 1 comma minus 1 plus y plus 1 into fy at 1 comma minus 1. This is the first term. I mean, 1 factorial term. 2 factorial term would be something like this. You should, when you are writing plus a and minus b, you should be a bit careful, guys. That's the caution that I would like to give you. fx6 at 1 comma minus 1 plus 2 into x minus 1 into y plus 1. You should be cautious. Even I might write some errors. I might write some printing mistakes kind. Okay. Next step. Y plus 1 and whole squared into fyy at 1 comma minus 1. That's the reason I've considered this example. You can as well go with the third order derivative, but since I have non-zero terms, since I have non-zero terms, except for 1 0 term, I'll be going with this. Okay. Yes. See all the values. This is minus e power minus 1. This is plus e power minus 1. Okay. Of course, e power minus 1 is common everywhere. Okay. This term would give me e power minus 1. Okay. At the end, I will take common, but as of now, first I will normally write. Okay. Plus 1 by 1 factorial x minus 1 into fx at 1 comma 1 is what? E power minus 1. Okay. Plus y plus 1 into e power minus 1. Okay. Which one has plus? Which one has minus? Let me look into it. Okay. First one has minus. Second one has plus. Third one has plus. Fifth one has plus. Okay. So, yeah. This one has a minus. This one has a plus. Okay. Yes. Plus 1 by 2 factorial into. Third one has a plus. Third one has a plus. So, what I'll be having? X minus 1 whole squared into e power minus 1. Plus is 0. Second, fxy term is 0. Plus y plus 1 whole squared into e power minus 1. Okay, plus 3 dots you will put to show that it's an infinite series. Okay, yes. Now if you take out, you can as well take e power minus 1 or just leave it as it is. There's no issue about it. Okay, I'll be having 1 here. And then for the 1 factorial term, I'll be having minus x plus 1. Okay, yeah, plus y plus 1. These are the terms. Of course, for the 2 factorial, 1 by 2 factorial, which is 2. Okay, e power minus 1 is taken common. Okay, so I'll be just writing these terms. It be looking something like this. Okay, e power minus 1 is taken common, right? Anything goes off, you can cancel out. If nothing goes off, you can just normally write e power minus 1, 3 minus x plus y plus 1 by 2 factorial. Okay, here I am just trying to stress upon when you have x minus a and y plus b. That's my motive. Of course, it's a trivial question. Again, a standard question which can commonly be asked. Okay, this is how I'll write the Taylor's expansion. Okay, there's one more example that I have done. Because of the length of the video, I'm not able to share it. I shall do that. Okay. Yes, I think this is clear. This is clear to all. If you can simplify, further you can simplify. Otherwise, you can just leave it like this. Okay.